Welcome in, folks. We're going to cover some file streams today. This is going to consist of a few sections. We're going to first talk about something called exception handling. This is kind of a prerequisite for setting up something called file streams. When we set up file streams, there are some possible exceptions that might happen. Exceptions are like errors that happen in the middle of the code. So it's kind of a prerequisite to talk about exception handling first. And then after that, we'll talk about two different types of streams. One is going to be called reading input. So we're going to be loading a file into a program. All right, and then next part, we're going to end off with the opposite, the writing output. We can think of this as saving data to a file. Okay, so the theme of today will be kind of talking about loading and reading from files. I just want to make sure folks understand the difference though between memory and storage. Memory versus storage. Do people know the difference between these? Memory versus storage? You can pull up a random picture over here. Let's see. Yeah, here's an okay picture. Memory versus storage. Do people know the difference? Well, if you take a look at your specs, your computer specs, like how much memory you have, how much storage you have, you'll see that your storage is typically a lot bigger. Most people are rocking like solid state drives. This right here, this is a picture of a hard drive, but generally this could be a solid state drive as well, which is a little more modern and faster. Storage, this is where files are stored. Like you know how in your VS Code, so in your VS Code, you see this Explorer over here with a bunch of files and folders. All of these are stored on your disk, your hard drive, your solid state drive, and then the memory. This is where programs are loaded into. So whenever you boot up a program, it's pulling it from storage and loading it into memory. Right? The reason why there's these two is just because memory is a lot faster. It's way faster to access data if it lives in here. However, the difference is kind of long-term versus short-term. Storage is more long-term, meaning if your computer turns off, your files still stay. But if your computer turns off, everything in the memory is cleared. By the way, it's you can call this a random access memory or hot storage, meaning there's only data in here when the computer is on. All right, so this is kind of a hierarchy. Today we're going to be loading data from the storage files into memory so we can have fast access. All right, so here's kind of a picture that I want to give folks. But before we jump into exception handling, I just want to show the theme of the future. We're going to be talking about saving and loading files. So we'll be ending up writing a program, and then sometimes it's necessary to load data into a program. Like if there's data that lives in some other file, it might be necessary to import this data into it. So this is called loading. In particular, reading. We're reading from a file. Okay, this whole time in class, we've kind of just been reading from standard input, like the keyboard. We would type something, press enter, and then it would go into the program. All right, we would type something again, press enter, and then it would go into the program. So it's kind of like the same thing. Instead of reading from the keyboard, we'll be reading from the data file. All right, and then towards the end of today, we'll talk about saving, which is the opposite, meaning when our program is done, it might be necessary to save the data back into this original file. The reason why is so you can load the program again later, and maybe you'll have the same exact data or same exact progress. All right, so this is kind of a general theme. If you kind of want to narrow down on it, you could think of this as like a game as well. Imagine you're creating a game. So some games have like a save state and a load state, meaning that when you boot up the game, it's probably gonna pull data from another file. there's possibly another file that will store data on the game. Like let's say you're playing a RPG game, right? Like let me pull up an example of an RPG game. I'm just gonna Google up RPG game in case that. So this stands for role playing game. Let's see. You can think of it as, let's see. I guess I could pull up like a Diablo. This is kind of an old one. Diablo 2. Let me put up Diablo 2. I've been playing this recently. So this is an RPG game. You can think of it like RPG, where you have like a health, you got stamina, and you got mana over here. These are all bars, or you can think of them as variables. There's also an inventory over here too. We take a look at the bottom right. This is maybe imagine it as a data structure that stores whatever the player has. So in some games, it'll have the save stored in another file, meaning when you boot up the game, it'll load from that file. All right, and then when you quit the game, it's typically going to save the data, right? Saving, kind of like overwriting this file, replacing all of these data with the updated version. All right, so yeah, that's kind of the theme of today. All right, first thing is first, I wanted to talk about handling exceptions. Before we jump into reading and writing from files, or loading and saving, we should talk about exception handling. The reason why is because there can be exceptions when we're creating file streams. Exceptions are things that can go wrong in the middle of the code execution. All right, so it's after compiling. So your code can compile, but there can possibly be exceptions in the middle of it. So let's talk about handling exceptions. In particular, I wanted to introduce this try-catch statement. This is kind of a new syntax we haven't seen yet. But a try-catch statement is a structure in Java where you would use this try block. The try block would contain code that can throw exceptions, meaning that if you have a line of code that can possibly fail, you should put it in here. You should put it in this block, because if it does fail, it's going to throw an exception that we should catch, and that's down here. So there's a catch. You can think of it as like an if statement, kind of like if an exception was thrown in this try block, it's going to be caught in here. So when we catch it in here, you can do some sort of recovery, or maybe just print it out, so to let the user know what happened. All right, so we're gonna apply this try-catch statement to an old program, just where can code throw exceptions? Well, in the very beginning of the course, we talked about input validation. This is like a way of reading input and determining if it's able to be kind of converted to whatever. Like let's say we had a scanner that reads from the system input. This is standard input, like the keyboard. And let's say we wanted the user to type in a number. So here's a prompt that says give a number. There is a possible place that the error can happen. Right over here. There's this code in the red is wrapped in a try block, because we can possibly have an error on this method, this parse int method. All right, just to visualize what's happening here, I'll pull up a J shell here so folks see what's happening. But basically, I'm saying that this parse int method can possibly fail. Like let's say I use the integer.parseInt. Okay, so this is a method that takes a string and converts it to an integer. So if I put like 10 here as a string, it's going to return a 10 as an integer. So we've seen this before. This is converting stuff. We can convert like a bunch of other numbers. See, here's a larger number as a string, and then this gives an integer here. But this method can possibly fail if we put some invalid numbers here. Like if we put a 0 here. So if I put 0 as a string, 0, press enter, this gives me a runtime exception, meaning that the code failed in the middle of execution. Right? And the reasoning is right here. It's saying can't convert, pretty much. You can't convert this because the method is expecting different text in here. All right, so yeah, code can fail, and it might be necessary to write a try catch in order to protect against it. So here we're gonna put a catch, which is a way of kind of recovering. There's not really recovery here. We're kind of just logging the error. This system.out, this is a way of logging, kind of like storing history. So here, let's try this out real quick on an old program. So in our VS Code, recall a long time ago, it was like week 1 or something. Week 1, we did this old program called input.java. Wait, no, it's called a car efficiency. Let me see, which one is it? Yeah, let's go to car efficiency. So this is an old program from a while ago. Let me go ahead and run it real quick. It's cd into examples, and then let me go ahead and run this. So all this program does is reads 2 inputs and does some math with it. It does some math with it and tells us the car efficiency. So the first input is asking for how many miles did we travel. So let's say we traveled like 60 miles, and then press enter. Now it's saying, oh, how many gallons did we use? Let's say I used 2 gallons. So if I use 2 gallons and press enter, the program says my efficiency is 30 miles per gallon. All right, so we did this a long time ago. There are some places that this code can fail though. See, the code did compile, and it had no runtime exceptions. But we can have runtime exceptions. Can folks think about how? See, let me run the program again. What if I type in like IDK right here? This is just like a string. So is it gonna fail here? Let me see. Let me press enter. So I press enter, and no, it didn't fail. It didn't fail. So this line succeeded. Right? The reason it didn't fail is because the method returns a string. So we're literally reading a string into this variable. Right? And then same with this gallons used. I could type in like IDK again, and this line is going to succeed, but this line is going to fail. Let me press enter over here. See, so I pressed enter, and we see that this line right here failed, line number 8. And the reason is because right here it says for input string IDK. All right, so people kind of seeing what's happening here. This is the error that's happening. It's a runtime exception. So the runtime exception is happening in these methods here. But basically, we're not able to convert IDK into a number. All right, so it might be necessary to do some exception handling if you want to log the error or maybe implement some sort of recovery. So the way we do that is by using a try catch. We would use a try block and put dangerous code into here. So it might be necessary to technically this is the only line that can really throw an exception. So yeah, your design can vary. I'm probably going to end up wrapping all of this in a try catch just to keep things simple. So here, let me put a try catch here. me put a try here. I'm just gonna wrap the whole thing in a catch. So there it is. I put a try, and then I should probably indent this just to make things a little easier to read. Cool. So I just put the whole, pretty much most of the main in here, and then I'm gonna put a catch here. All right. Let me explain this as I type it. Okay. Cool. So I just wrapped dangerous code. This is really the only dangerous line here, but there can possibly be an exception here, and if we catch it, it's gonna land in here. But we do need to kind of describe what kind of exception can happen. There can be multiple different types of exceptions, but the most general one is the capital E exception. This is kind of like an umbrella. If you want it to be more specific, you could there is something called IO exception. I forget. I gotta look at them. There's other types of ones too, but this one is the most general one, meaning it should catch all possible exceptions. All right, and then this name here doesn't really matter. This E, you can name it whatever you want. But basically, this is useful for like accessing the error. So if you wanted to access the error, you could print it out over here. You could say something like error. Here, let me do a printf actually. Printf error, and then let me point at it. Let me point at it and say it's gonna be some string. And then this string, I'm trying to represent the error message. So the error message you can grab from this. There's an exception variable here. This is kind of, it contains data on what happened. So you can do like e.getMessage. This is a getMessage is a method that belongs in the exception library. So you could print out the message here, and let me test it out real quick. So Java card efficiency. Okay, so I'm running it, and let me just run it normally first. Like I'm putting some valid integers, valid numbers, I mean, and then 2 here. Yeah, so the program ran fine, but let me run it again with like IDK. Okay, so I press enter here. This line succeeded. Let me do IDK again, or yeah, IDK and enter. And what happened here? You see how we didn't really get the exception again? We didn't really get that long exception that we got earlier. This is what we got earlier. And now with the new try catch, it's giving us a cleaner error message. This error message is coming from here, right here. All right. So yeah, you could do some recovery if you wanted to. But this catch is technically not really doing any recovery. It's really just logging the error. Logging the error means to like kind of save the history. This way, maybe a future programmer can study all of the error messages. All right, so this is logging the error. Ideally, you'd want to do some sort of recovery. So I'll let folks think about this, maybe as lab time or something. Maybe implement some sort of recovery. By recovery, I'm talking about like ask the user again to say like, hey, please type in an actual integer. So you could imagine like a print statement here that says, please type in a valid number. All right, so this is still not recovery. It's telling the user, but you'd want to do the recovery over here, like maybe some sort of loop. So I'll let folks think about it. Ideally, you'd want to loop this until this line succeeds. All right. There is some reading that gives some hints on how to do this. If you want to take a look at the exception handling, it's in 11.3 over in this resource. 11.3. Let me take a look at it. Exceptions. Let me see if they talk about how to do this. Yeah, it's somewhere over here. Yeah, it's this first part over here. So over here in the first part, they talk about handling exceptions, and one way of recovering is by looping the input. So you'll see a loop somewhere down here. Let me see. Yeah, you see this loop right here. This loop. Let me zoom in. It's pretty much wrapping this try. It's pretty much saying try to convert it over and over again. And if it fails, we're gonna throw an exception and just try it again, because this code is in an infinite while loop. So the code is gonna try this over and over again, and when it succeeds, it'll be able to quit the function. I mean method. So yeah, you should look into how to recover. Okay. Cool. Yeah, this is very useful stuff. Exception handling. It's not too important for this class yet, but at a bare minimum, you should know how to catch a general exception, which is this most general one here. You could be more specific if you wanted to narrow down what type of exception. Let me see. Let me go to reading over here. Let me see that I have some examples. Okay, they don't have a list of examples here, but you could Google up like exception handling in Java, and then let me see. Let me go with W3 schools. They're gonna talk about. Oh yeah, here. So there are tons of different types of exceptions. If you wanted to be more specific, you could do like arithmetic error, IO exception. This is this is general. If you wanted to be more specific, you could say like IO exception. It just depends on what type. All right, for example, this method throws a certain type of exception. So you could look at it, this method over here, this double.parse double, to see what type is throwing. So let me just take a look. Let me look at the parse double. Okay, here's a method. Let me take a look. And okay, so this method can throw two different types of exception. It looks like the one we're dealing with is this one called number format exception. So you could be more specific and say catch a number format exception. The reason why you could be more specific is because you could catch more. You could chain them and be like catch another one. You could catch another exception, another type E. Right, I'm keeping it super general, and you could catch another one, another one E. So yeah, there's many types of exceptions here, but I'm gonna keep it super general. Exception. This is like the it's like an umbrella. It pretty much captures all of the possible exceptions, like all of these over here. Okay. So that's just a quick intro on handling exceptions. The reason why we're talking about this is because we're gonna move on to creating file streams. We're gonna end up reading or loading, loading from a file and then saving it to a file. But this is kind of a dangerous. I mean, it's not really dangerous, but there could be exceptions here. Like one exception that could happen is you could try loading from a file, but maybe someone accidentally deleted this file. Right? Like in that case, there should probably be some sort of exception. Maybe the program will say file doesn't exist, because we tried loading data from something that doesn't exist. All right, so that's some possible errors. All right, so here's a quick sneak peek. Well, we're gonna apply this in just a bit, but a file error. We're gonna end up writing a try block that reads from a path. All right, so don't worry about this CSV file here, but basically, I'm creating a stream. Like I'm setting up a program to read from a file. And in particular, this file is called customer shopping behavior.csv. All right, we're going to end up downloading this file later. And then there's this code here that can possibly throw an exception. It's possible to set up the scanner to read from a file location. So we'll talk about this in just a second. I'm gonna move on to the next slide just so you see what's happening here. Okay, so let's talk about reading input. This is loading data. All right, this whole time in class we've been kind of doing streams from some sort of source. Like when we set up a scanner, you've seen that some sort of argument goes into these parentheses here, and this argument represents where to grab the data from. The first type of source we saw in this class was a system.in. Okay, so system.in is a source. You can think of it as the keyboard, but if you were to continue computer science, they're going to call this standard input. Because the standard input is also other types of things too, not just a keyboard. But yeah, for this class, you can think of it as a keyboard, meaning that we're setting up a scanner to let the user type some stuff in. All right. So yeah, you've seen this. Well, we're gonna move on to a different type though. We're gonna move on to something called reading from a file. Okay. So this is kind of one way we can read from a file. If you want to take a look at it, now let me pull up this constructor methods here. You can actually Google this. You can Google up a scanner in Java, and then take a look at something called the constructor. So scroll down a bit over here. You'll see something called a constructor summary. And these are all pretty much the same methods, but they take different arguments. We've seen this one before. Input stream source. Basically, when we're constructing a this right here. So this is called constructor. We're constructing a scanner that reads from the system input, and a constructor is a method. So the method that we're calling here is this over here. Saying scanner, and then we're putting the system input here. But there's other types of constructors too. Like we could create a scanner that reads from a path. All right, if you're curious what a path is, it's kind of like a pointer that locates a certain file on your computer. So if you had like a file called like file.txt, then you could read from that file by creating a path from it, and then putting the path in the scanner, into the scanner constructor. All right, so this right here is using this constructor over here, this scanner path. So as you'll see, there's multiple ways on reading from a file. This is one way. There's more as well. Like this is another way. It's pretty much doing the same thing. But here, let's go ahead and set this up. This way we can have an example. Let's see. Maybe we should download some data. So I'm gonna go on Kaggle. As you saw from the last class, Kaggle is kind of like a place that contains coding competitions. It's got data sets and models too. Models are like algorithms. Let me click on the data sets because I want to download something. So you can download data sets from a lot of places. Kaggle is one of the good places. Let me see. Let me sort these. I'm just gonna sort it by most downloads to see what people have downloaded the most. Okay, as we see here, there's a bunch of data sets. They're all different sizes. Like this one right here is 1 megabyte. This one right here is 19 kilobytes. These are data. You could take a look at some, like here, data set of songs. Let me take a look at this, see what it is. Okay, so it looks like someone created a data set that contains information on songs. Let me take a look at this. So it's a tabular data set that contains labels, useful for machine learning. So you could take a look at this. Let me download it actually. Let me download it. Okay, I just downloaded it. Let me open it in like Notepad or something, or VS Code. Either way it works. I'm gonna open it in Notepad. Okay, cool. So I just opened it up in Notepad here. This is the file I just downloaded. It's kind of large. It's got like a lot of lines here. It's got 100 lines. Oh, it's not that large actually. But the point here is this is data, and the first line kind of represents all of the features. So this is saying that all of the rows is a single song. So this first song is named this over here. The artist is this. Oh, and then it came from some movie. And the language is this right here, and then the emotion is joy. So yeah, the header is describing all of the features below. So you could scroll down a bunch more. Let me look for like an English one. Yeah, so here's one that's English. So once again, this is like the title. This is the artist, and then I guess it came from some movie. I don't even know this was a movie. Uptown Special, and then a language, and then the emotion. So this is some data, and it's sometimes necessary to read data into a program. So here, let me find another data set. Okay, let me look for another one. Okay. There's this data set here called Customer Shopping Behavior Analysis. This is I'm not sure if it's a real data set, but basically this data set contains information on what customers have purchased. Once again, I'm not sure if it's real. It's probably generated, but it's good to practice with. Let me take a look at it. Let me download it. Download. Okay, let me open it in Notepad. I'm gonna open it in VS Code later. Notepad. Okay, I just downloaded a data file. Let me zoom in a bit. And as we'll see, there's a lot more features here. This top row is describing how many features. So this is one line, by the way. It looks like two, but it's just Notepad kind of wrapping it to the next line. But yeah, see there's this many features, and that's kind of describing all of the rows down here. So this is like a single row where we got the customer ID, we got their age, we got some other features like what item they purchased. Right, this is referring to here, the item they purchased, and a bunch of other features too, like how much did they spend in US dollars. So this person right here spent $68, and then yeah, a bunch of other features. So let's go ahead and deal with this data set and kind of load it into a program. All right, this is gonna be a pretty cool project actually. Or actually, you know what? Here, let me find another one. I feel like people might be getting. Okay, I'll consider that one. Let me see. I saw an earlier one that looked cooler. Let me see. Yeah, you know, I'll just stick with that one. There's a lot of interesting data out there. Anyways, I already downloaded it. It's over here. It's in my downloads folder. It would probably be necessary to move this into a directory that VS Code can see. So let me go ahead and move it around. Let me go create a... I'm going to create a folder here. So in our examples, I'm going to create another folder. I'll call it like shopping behavior. I'll call it shopping behavior. This is a folder, by the way. Okay, so I just create a folder. I'm gonna go ahead and drag that data into there. This way it lives a little closer. Let me see. Okay, so it's right here. Let me copy it. See, so I have it in my downloads folder. I'm gonna copy it into my CS-12J folder. Put it in here, shopping behavior, and then paste it. Okay, there it is. So I'm just moving some stuff around just to make it easier to access. Okay, cool. So now I have the file here. And yeah, you can open it in VS Code too. Okay, so I just opened it in VS Code. This is a data file. CSV stands for comma separated values. It actually doesn't matter what the extension is, but yeah, .csv just describes it. Okay, so let's go ahead and create a program that reads from this whole file. All right, there's a lot of lines in this file, by the way. There's like, let me see. There's like 5,000. There's like 5,050 lines. So, and each of these lines represents a customer who is shopping. All right, like for example, this first one, it looks like each customer has like a unique identifier associated with them. They have the age, the gender, a bunch of other features. Let's go ahead and load this file into a program. So I'm going to create another file here. I'll call it like I'll call it main.java just because I'm not sure what to name it yet. I'll name it main. Okay, just the entry point of the program. Okay, this should be a pretty cool thing. All right. So first things first, I wanted to introduce this scanner. So when we're reading from a file, which means to kind of open a file and get ready to take input, we could use a scanner and construct the scanner with a file location. So let's go ahead and do that. We could say a scanner, I'll call it like file input. Okay, and I'll set it equal to a new scanner and something here. So this is called constructing, by the way. Let me comment this. Constructing a scanner with a file location. Okay, if anything, I just need to put a argument in here, and I'm planning on using this method, this constructor method. There's this constructor method where you can give it a path. The path is kind of like it's like a variable that represents where to look at. And since this file, this CSV file, is inside of the same directory, we can just say plainly. We can just say plainly the name of the file here. So one way you could do that is saying like paths.get, and then here this is the name of some file location. Customer shopping behavior .csv. Okay, so yeah, this is the name of a file. I'm putting it inside of a paths.get. The reason why I'm doing that is because this is a method that returns a path variable. All right, you'll see that in the reading. They'll talk about it over here in the 4.3. So let me take a look at it over here. 4.3. Here it is. You'll see they do something like a paths.get. You don't have to do it this way. You could create like a variable for it if you want. Like you could create like a path and then call it like file location, and then set it equal to this over here, and then say this is equal to a file location. So yeah, this would work too. It's a little easier to read. I'll stick with this over here. Okay, let me go ahead and try running this real quick. Try compiling, I mean. So I'm gonna cd into here. This is a new folder. Cd into shopping behavior, and then let me try to compile and run it. Okay, so I just compiled, and it didn't even compile. There's a compiler error here on line 5. So it's pointing here that the compiler is telling us that we should be safer. All right, that it's saying we should try to catch the possible IO exception. This line is possibly dangerous. It can possibly fail, especially if this file doesn't exist here. Like let's say I put something, right? I'm just put like random something.csv. Okay, so this file doesn't exist, meaning if we were to try to open it in a scanner, there's probably going to be some sort of exception, and the exception we should catch, so we know if it didn't exist. All right, so let me put shopping behavior here. It's pretty much telling us we gotta wrap this in a try catch. So let me wrap this whole thing in a try catch, because this highlighted line can possibly fail. In particular, it could throw an IO exception. All right, so you could capture it. If this fails, it's gonna throw an exception that we can catch here. So we should describe the type of exception. All right, you could describe it as IO exception. Or you could describe it as IO exception, but I'm gonna keep it super general. Just exception. Just because this is an umbrella, and it'll capture any small exception. All right. So let me put an error message here. Let me go print f actually. I'll say error and then point at what the error is. One way you can access the error is by using this exception variable. This is what we catch. If this throws an error, we'll catch it here. So we can access it as e.getMessage. This is accessing the error. All right, so let me go ahead and compile this. Okay, so compile, and then, okay, cool. It compiled and it also ran. But there is no output because I don't have any print statements. But check this out, check it out. Everything ran fine. But let's say I accidentally made a typo here. Like, let's say I put something.csv. This doesn't exist. But what's gonna happen? Let's see. Let me run it again. All right, you see what happened here? It's it had an error message. The error message happened because this file didn't exist. So since the file didn't exist, this next line failed, and it threw an exception that we caught here. And the message didn't really help that much. It looks like the error message kind of just pointed out this file location. But yeah, people kind of seeing what's happening here. This is a really good protection because the data can maybe disappear on accident, Like if you were to accidentally delete this, then this line would fail. Alright, so let me run this here again. Okay, cool, it runs, it does nothing. Okay, just a quick side note here. I'm using something called a relative path. Okay, a relative path is right here. It means that the path is relative to where this main is stored. So the main is stored in this folder called shopping behavior, and the file is also stored in this same directory. So by relative, it means they're in the same folder, and we don't have to specify where it's living. But if you're using, if this file were to live somewhere else, like maybe it lives in your C drive or somewhere else, you can maybe imagine you have to use something called an absolute path. So if you wanted to use an absolute path, absolute path means it kind of starts from the root. Like root, I'm talking about, let's see, like if you're on Windows. If you're on Windows, you've probably seen like this over here. Let me go to my, you see how on top, you see how in the address bar, the top starts off with like C drive. This is like a hard drive, and then it goes into users, and then Andre, and downloads. So this is an absolute path. So you could use an absolute path if you wanted to, like C drive, and then / let me just paste it actually. Over here. So you could put in the absolute path here, and then oh, I think I need a double / these over here. Yeah, I think I need a double / these. If you might remember from assignment 1. Let me if you remember from the very first assignment, we had to / to treat them as the actual characters. So let me escape all of these. There's a better way on doing this. You can use like a raw string. Let me see if this works actually. File location. Oh, I need to save this. Save and rerun. Okay, cool. So yeah, we just did the same exact thing. But basically, this is a absolute path, which starts from the root, and this is like a relative path. The relative path starts from where the main is stored. So the main is stored right here in the same directory. All right, I'm gonna use the relative path because it's easier to read. And this absolute path is kind of leaking information. It's leaking my whole file directory. So you might not want to like publish this type of code. Okay. All right, let me make sure this still runs. Okay, cool. So all we did was construct a scanner that points at a file. All right, it's pointing at this file over here. It might be useful to start analyzing this. Like maybe we could start parsing each line. So this is like line 1. This is actually a header. It's not really actual data. It's kind of describing what the future data looks like. So you could extract the header and kind of measure how many features there are. Like see, there's 1 feature here, 2, 3, 4, 5, 6, and keep going. I'm not sure how many there are, but we could write a program that counts how many features there are. All right, let me go ahead and grab that then. So you might remember this method called readLine. or next line, I mean. This is a this method is it's a scanner method that returns a string. The string represents what the scanner grabbed. So you could store it into a variable. I'll store it into a variable called a header. All right. So the header is kind of representing this whole string here. Let me print it out real quick, just to sanity check. Header is, let me go string here. Okay, let me test this out. Okay, cool. So it prints header is, and then it's really just spitting out the first line that we grabbed. All right, this whole line here. It might be useful to separate them, because this is technically a single string, and it doesn't really let you know how many features there are. So if you wanted to separate them, there is a method. There is a string method called split. It's over here. Let me string methods. Actually, you can just look up strings in Java. So look up strings in Java. There's a method here called split, I believe. Let's see, split. Yeah, so there's a method here called split. It basically, you basically give it a regular expression. A regular expression describes where to split it on. Here, let me pull up a J shell here. This will be easier to read. So it's kind of like let's say you have a header. So this is a string. All right, let's see how a string header is equal to let me call it like, I'll just call it like foo, comma bar, comma baz, right? Just three random strings. All right, it's possible to split this into a data structure. So this method right here, it'll split a string and return a string array. That's what this is describing here. Meaning that we could say header.split and say to split it on a comma. Okay, so this returns a string array. A string array is a data structure. In particular, this contains however many strings, 3 in this case. So you could, if you wanted to, you could split this here. Like, I'm planning on splitting this header. I'll call it like features. I'll call it features actually. Yeah, let me call it fat features. And it does return a string array. So a string array is dumber than an array list. You've seen this stuff last week. But you could say this is equal to a header.split, and then split based off commas. So this is saying split the whole string, and it returns a string array. So I'll store it into this array called features. All right, you could do it like this. Let me make sure it compiles actually. Okay, compiles and runs. And then if you wanted to, you could print out the length of this features. Like how many are there? Number of features is some number features.length. But basically with an array, you can get the length with dot length. It's a little different from array list. Okay, so let me run this. Okay, cool. Cool. So we see the number of features is 17. All right, this pretty much means there are 17 commas in here, pretty much. All right, people cool with this? Cool. So far, all we did was parse the very first line, meaning we implemented a scanner to consume this line. It might be necessary to start looping through the whole data set, because you might want to maybe do some statistics. Like maybe you wanted to find out what is the most common item purchased. Right, this is a feature. Or maybe you wanted to find out what is the average money spent. Right, there's a bunch of things you can learn from this data. But either way, we still have to loop through the whole input. All right. So it might be necessary to loop that. I'm gonna loop it as a while loop. The reason why I'm using a while loops are good for possibly infinite things. All right, and in this case, we don't really know how much there is. Well, we do. We can tell by looking at the size of this file. But sometimes you don't know, and it's necessary for a while loop. So you could say something like while the scanner can look at more lines. Okay, people remember what this method does? Has next line. This is a Boolean method. Oh wait, I'm using the wrong thing here. I meant file input. So has next line. This is a scanner method that tells us whether or not there's data still in there. If you're curious, you could look at the scanner again. I'm using this method here. Has next line. It returns a Boolean that represents if there's another line in the scanner. Okay. So let's see. While file input has next line, we're gonna go ahead and consume it. So we could consume it by saying file input dot next line. Right, this is a method that consumes the line. It also returns a string. So you could store it into like something called a row here. It doesn't matter what you call it, but I'll call it row. Actually, is this a good name? Let me think. You know, I'll keep it super general. Let me call it. Yeah, I'll call it. Yeah, let's see. Yeah, I'll call it line. Actually, I'm gonna be super general. The reason I'm calling it line is yeah, just to be super general, and you'll see this in the next thing I'm gonna write. Let me sanity check this. Yeah, let me sanity check it. I'm just gonna print out what the line is. Let me print it as a f string. Analyzing line. Okay, let me analyze a line, just put it here. Okay, I should get a bunch of output in the terminal. Let me test it. Test it. Okay, cool. So it's analyzing the lines. We saw a bunch of data, and it looks like the program ended here. The loop ended here. Let me just sanity check this on by comparing it to here. So I'm gonna scroll all the way down to the bottom. And yeah, it looks like our program is consuming all the lines because we see the output is describing this last line in the data set. Okay, cool. So I'm just sanity checking, making sure it's going through all of it. These are single strings. Sometimes you might want to split it. Right? Like, you know how earlier we split the header into a bunch of features? You could do the same thing if you wanted to. Like, you could say you could say something like a string array. Here, let me delete the sanity check over here. We could split this line. So split based off of a comma, and it does return a string array. So if you wanted to, you could store it into like a string array. I'll call it like rows, or I'll call it like customer features. Yeah, I'll call it customer features. Okay. So this is splitting the whole line, and then now if you wanted to access individual things, you could go into the array. Right? You might remember you can access things in array, like if we wanted to print out the item purchased. The item purchased is represented by the number. Let's see. So it goes 0, 1, 2, 3. So you could access the element at position 3, which represents the item purchased. So customer features at 3. This is accessing something in an array, but this does return a single string. So if you wanted to, you could store it into like a item purchased. And then now if you want to do sanity check, let me just print out customer purchased some item. Item purchased. Okay, let me go ahead and test this over here. Java, and yeah, people see what's happening here. So there's a bunch of lines in my terminal, but basically it's going through the whole data set and isolating one part of it. So let me make sure it's correct. I'm gonna go to the bottom here. Okay, so this is the bottom of the data set, and this is the bottom of my terminal over here. And yeah, let's see. So the last item that was purchased was a blouse, and yeah, that's right. Second to the last item purchased was sneakers. Looks good. Skirt. Yeah, looks good. It looks like the data is all good. So can people kind of see what's happening here? This loop is going through the whole file, and we're not really doing anything with it. We're kind of just splitting it and accessing the element at the third position. But maybe you wanted to find out like what is the most frequently purchased item. All right, what's the most frequent? You might remember this is the mode. Do people remember last week? Let me pull up my slides. You might remember last week we talked about finding the mode. So you might have to revisit the last lecture if you haven't seen it yet. Let me pull this up over here. Last week we spent quite a bit of time talking about finding the mode, which is the most frequently appearing element. So if you wanted to find out the most frequently appearing element, well, first of all, it might be necessary to store all of these into some data structure. Right? The reason why is so you can go through that data structure and start counting things up. Right? Remember that from last week? You would kind of store things in a data structure. Right? So this is like we're storing it into an array list, and then later on we can start counting things. We can start counting, but like, hey, how many times does this first element happen? Right? And then keep going. This happens once, so we update the mode. Right? You can do that again. Anyways, we did this last week. There is a file here called mode.java. So this is from last week. If you might remember, we wrote a method that takes an array list of strings, and then the algorithm goes through that array list and tells us what the most frequent element is. All right, so we could use this we could, let me copy this over. Let me copy this whole method over. So copy, and then let me paste it into here. See, we could, okay, there it is, I pasted it. We could use this. If anything, we kind of need to update our program to use an array list. Right, like we should probably store all of the purchased items into an array list. This way we can pass that data structure all the way into this method here. All right, so you could create like a array list. Let me go ahead and create one over here. I'll create over here. I'm gonna create an array list of strings. I'll call it like items purchased. Okay, and I'm using singular, I mean a plural here, items with an S. So it's a little different from this one, item purchase. All right, so this is a plural. I'm gonna say it's equal to a new array list of strings. All right, so this is like a data structure that stores all of the items purchased, meaning that whenever we stumble upon an item purchased, we should add it to this data structure. All right, populate this array list. So we could populate it and say items purchased dot add. Oh, let me delete this print statement. Dot add item purchased. Okay. I know this might look a little hard to read, but basically these two are different. So we have a singular item purchased, and we have items with the plural. The plural is representing the array list, and then the singular is representing a single string. Okay, so this line right here is populating the array list, and now we could go ahead and maybe sanity check, right? Like outside of the loop, this is when we finish parsing the whole line, parsing the whole file. So we could do a sanity check and maybe print out the size of this array list, right? Like number of items purchased is some number, and the number is the size of this array list. So this is yeah, you can do an array list and that they know its own size. Just takes a method here. Okay, let me test this now. So Java main, and okay, here let me remove this first print statement. These are just sanity checks here. Remove these. Okay, let me go ahead and run this now. And okay, cool. So number of items purchased is 5050. 5050. So I'm sanity checking the size of the array list. And yeah, this looks about right, because how many items are here in this data set? Well, let's see. So you can tell by the line numbers, right? So ignoring the first one, because this is the header, there are 5,050 lines. You see how the last one is 5051. So yeah, it looks like our size is correct. Meaning we could pass this array list into the method. Remember, our whole goal was kind of to find out the most frequent element. And there is this method we created a while ago. We could just pass it into it. We could pass it into this method called mode, and yeah, give it the array list. Right, we could give it the array list, and then I mean this does return a string, so you could store it into a string. I'll store it like most common, and then let me go ahead and print it out. Remove this one over here. So this is most purchased item is Most common. Okay, let's go ahead and see. So I'm gonna go ahead and run this now. So Java, and okay, I'm getting a bunch of print statements here. I think I left something. I think I left the print statement in the function method. I mean. Okay, cool. Yeah, I did leave something in here. You don't really need this. This is kind of tracing the algorithm. If you're not sure what's going on with the mode algorithm, you could do some print statements to visualize it. Let me get rid of that. Okay, let's run this again. Okay, so I just ran it and it says the most purchased item is shirt. You could sanity check it by counting manually. Let me just look through here to see what's the most common. Or you could sanity check it by bringing it into Excel, right? Like Google Sheets or Microsoft Excel. Those programs have the ability to load CSV files and do statistics. So you could do the same thing in there. So yeah, it looks like most purchased item is a shirt. Let me Control F this. Let me look at shirt and case sensitive. And yeah, it kind of looks like it's the most. Yeah, there's a bunch of shirts. Yeah, this makes sense. A shirt is the most purchased item. All right, people okay with this so far? Okay, quite a lot happened here. Let me start commenting some lines in here. Let me collapse this. Yeah, quite a bit happened. Let me see if I can comment anything here. Okay, so we constructed a scanner that points at a file location. We extracted the first line. So let me go and comment this out. So this is a consume the first header line. All right, consume the first header line means to grab this very first line. It's not too useful. It's arguably useful, but for the actual data, we should look at the next lines over here. So yeah, this is consuming the first header line, and these are just print statements. Here we're creating an array list. Create an array list to store the purchased items. All right, so we'll create that, store the purchased items. But this while loop is where the magic is happening. So this while loop says loop through the rest of the file. All right, so we'll loop through all of the lines in the file. All right, line by line. And then we're pretty much consuming the line. All right, so this is consume the line, and then split. Right, down here we're splitting it. Split the line into features. The reason why we split the line into features is so we can individually access small individual features. All right, and then here we're just gonna populate the array list with the element. All right, the element is the feature. It's the at the position 3. 0, 1, 2, 3. All right. Let me clean this up over here. These are just sanity checks. Okay, any questions about this, folks? Okay, cool. So this was kind of an example of data analysis. All we did was write a program. We downloaded some data from the internet. The data lives on our hard drive, so we implemented the program to load from there. All right, that's really what we did here. So that's right here. We're setting up the load behavior. All right. Next up, we're gonna do save. But let me let me summarize what we just did so far. Okay, we did some reading input. This is just one way reading from a path. Some applications. What is this useful for? Hopefully people are kind of seeing, if you were to think of it in the game sense, this is like loading a previous save. So you could create like a game, right? It doesn't have to be a program. You could create a game and then maybe a save state that contains data on your character, and then you can load it in, right? You can create a scanner that reads the data and then loads into the game, so it has up-to-date data. All right, so that's one use case. We can do a lot of data analysis as well, and that's kind of what we were doing here. Some very small data analysis, and we downloaded it from this website here. There's the Kaggle. There's tons of data here. If you want to scroll through it, let me scroll through all of it. I'm gonna sort it again by most downloads. Okay, let me refresh. Looks like their website is broken. Okay, I'm just gonna look at the computer science category. Okay, it looks like they have data on California housing prices. This is an old data set, 8 years ago. Let me take a look at it. You could do some data analysis to make predictions. Let me take a look at this. It's 1.4 megabytes. It's got a bunch of data. Let me just download this. It's not a big file. Oh, it's in a zip file. Okay. Let me open it in Notepad. Okay, so here's some data here. Okay, this data might be a little hard to read, but it looks like it's storing the latitude and longitude. This is like coordinates on the globe. And then it's storing the median age. Okay, here, let me look at another one. I feel like people are getting tired of looking at numbers. Let me look at another one. Let's see. A lot of AI stuff. Oh, they have a data set on spam versus legal, legitimate emails. What else? A lot of AI stuff. Gold price. Yeah, you can do a lot of things. So with data analysis, if you're planning on becoming like going further into computer science, you're likely to be asked to analyze large amounts of data. This is also a trendy topic nowadays too, with machine learning and artificial intelligence. A lot of those are data analysis. It relies on that, meaning you'd have to, if you were to create like a machine learning model. Machine learning is the study of detecting patterns. Here, let me just pull up a more formal definition. Machine learning is a part of artificial intelligence that learns from data and generalizes unseen data. This means to create algorithms that can detect patterns. So by being able to detect patterns, you'll be able to create AI algorithms in general. All right, pretty cool stuff, right? Data analysis. Okay, Let's move on to the next part of this class, and we'll pretty much be done. So we just finished these two things over here. We talked about exception handling, which is a prerequisite for streams. Let's talk about streams again, but the opposite of reading. All right, the opposite of reading input is writing output. Okay, we've seen writing output before. On the day one, we did a hello world. This is one way of doing it. System.out.print in the hello world. System.out is the destination. It represents where to print it. So you'll see this in this class. You can think of it as a terminal or a console. The more formal is standard output, but yeah, you can think of it as terminal, meaning that whatever you print line, it's going to go straight to your terminal. All right, but sometimes you might want to write the data to another place. This is kind of like a saving, in general, when you finish the program, maybe you want to save the data back into it. Right? In some cases, especially with games, right? In games, you would read the data, and then when the game is done, we would save it back to its file. So we're planning on doing exactly that. And so another way we can output is by creating our own output stream. And one way it's called a print writer. This is a new type of variable. It's basically you're making a new destination. So here I'm creating a destination called writer, which is pointing at this hypothetical file. And then you can do a very similar method. You can say writer.println, right, and then hello file. And what this does is it puts the string into this destination, right? Instead of the terminal, where it's going to live in a file. All right, this is a file location here. Okay, so let's go ahead and apply this. Let me look at this code here. I'll probably use a different example. Let me quit all of this. Let me look at another example to see if we can save something. Let's see. Maybe roulette. Let me see roulette real quick. I'm thinking about modifying an old program to save the data somewhere. Like maybe roulette. We could imagine play the game and save the history into some file. Maybe. Let me see what roulette looks like. Let's see. Thank you. Come again. I'm thinking. See, instead of saying system.out, I'm thinking about making it say like have it output to another file. Let me think. Then I have to do all of these. Nah, here let's keep it easier. I guess I'll do like a. I guess I'll do it in this main. This shopping behavior. Nah. Okay, you know, I'm gonna make a whole new example for this. It's gonna be really small though. It's gonna be very small. Let me just make another example here. I'm gonna call this. It's gonna be really small. Let's call it like. I'll call it output to file. Okay, so this is gonna be an example of outputting to the file. gonna start off with a small main. Okay, so let me just start off with a small hello world. You don't have to type this. Hello world. Okay, this is like day one. Let me go ahead and run this. Java output to file. Make sure this runs. Okay, hello world. So this is printing to standard output or our terminal. But sometimes you might want to store it into a file. And you can do that by creating a object. You could create like an object that represents the location of some file. And this is one way. It's using a class called print writer. So you could do something like instead of this, you could create like a print writer. I think it's capital W here. And you can call it whatever you want. I'll call it file out. And then I'll set it equal to a constructor. So here I'm pretty much saying construct a print writer that comes from this location here. I'll call it like a file.txt. All right. This doesn't exist, but with an output, it could possibly create it for us. All right, and just to keep things compiling, we see it doesn't compile here because there's a possible exception. It's saying that we should probably wrap this into a try catch. The reason why this can fail is if you use like an absolute path, it can fail. Like let's say, whoops. Like let's say I were to create another one and said like C drive or something, and then maybe users and then Andre or something. This is an absolute path. It's totally possible for an error to happen if one of these folders don't exist. Like if this folder Andrew didn't exist, it's probably gonna have an exception here, like a file not found, saying something like, oh, this folder doesn't exist. So it might be necessary to wrap this in a try catch. All right, and I know this doesn't exist here, but with an output, it's going to kind of make it exist. It's going to create it if it doesn't. All right, so I'm going to put this in a try catch just to get rid of that error. Okay, and I'm going to keep this super general. Exception E. Print on error message here. E.get message. Okay, let me test this now. Okay, cool. It does run. So once again, the reason why we needed this is because this can possibly fail. It can really just fail if you use an absolute path, and if part of the absolute path was mistyped. But here I'm using a relative path, so it should still be fine. Okay, and check this out. So with this right here, this line is saying construct a let's see, construct. It's kind of like a pointer or like something that represents the location. I'm going to say construct an object that represents the output file. All right, so it's technically a print writer object, and with here you can use methods. You could use print writer methods. Like if you wanted to look at the print writer, I'm going to use this method over here called print line. So you could look at this over here, print writer. This is a standard class. Print writer. I'm planning on using these functions over here, methods over here. See, there's a bunch of print line methods. You can give it different types of variables, and it's really gonna dump it out to the file. I'll probably use this print line over here that takes a string instead. So you could do like file output dot write. Wait, no. Dot print line. My bad. Dot print line, and then give it a string. So some sort of string here. I put like hello world, and yeah, that's it. Alright, so this is gonna output it to this file here, which doesn't exist, but it's gonna be created. And then as a good program practice, it's a good idea to close it. Whenever you have like an open handle, it's typically a good idea to close it. It's kind of like having an open tab. You see I'll have a bunch of open tabs here. When I'm done with it, you might want to close it, because it's going to save memory. It's going to save memory on our computer. So if you don't close it, you can possibly have memory leaks. So here I'm going to say file output.close, so we don't get file leaks. Memory leaks, I mean. Okay, let me go ahead and run this. So check it out. There's gonna be some cool magic here. Okay, and I'm loading up my file explorer, so you'll see what happens. Oh, it looks like I already have a file here. Okay, this is empty. It's an empty file, which got created earlier when I ran it. Let me delete this file here. Delete. It was created because I ran this program earlier. So check it out. So I'm gonna run this program. Right, cool. I just ran it, and we see this brand new file. You see how it just appeared? So this is brand new, and we take a look at it. It says hello world. Right, people see what's happening here. You can run it again. You can say, I'll say like testing. See, I'm running it again, and check it out. So I just saved it, and when I run it, it's going to end up overwriting the file. So I just ran it, and then now if I take a look at the file again, this is brand new. See, it says testing. So you see what's happening here. I do want to point out something dangerous that can possibly happen right here. So I'm careful here. By opening up, it's clearing the contents. By default, the file contents are cleared. Okay, meaning that I could leave this out over here. All right, see, if I leave this out, the program is going to open this, and just by default behavior, it's going to remove everything in here. It just removes everything in preparation for outputting some stuff. So be careful with that, because if I run it here, and then now if I take a look at the file again, it all got removed. All right, so yeah, be careful with this, because you could end up opening like precious data, and if you open up that precious data, it's gonna get cleared. All right, so you could end up accidentally removing file contents with this. Okay, let me bring the testing here again and run it. So run it, and then now we get testing here, and then you could run it again, like I'll put like hello world, and then run it again. So we run it again, the file gets cleared, and we dump out 2 lines into here. So that looks like over here, 2 lines. Pretty cool, right? If you didn't want to clear out the contents, you might want to look into something called append. If you don't want to do that, don't want the contents cleared, you could look into something called appending. Look into append mode. All right, so let me see if append mode means to not clear it. It means you're opening up the file to put stuff at the end of it. That's what append means. It means put stuff at the end. So you could look into append mode. Let me see if there's over here. It might not be called append mode actually. Oh, it might be a flag. Okay, it looks like there's a Boolean flag. Let me see if this is gonna work. I don't think this is gonna work actually. I forget the syntax. Let me try a false here. Okay, cool. That didn't work. I'm trying to. Oh, that didn't work. Why not? Because I'm using a string here. Let me see. Without automatic line flushing. Okay, let me just Google this. I'm gonna Google up print writer append mode in Java. Okay. Let me see. Just Stack Overflow. Let me check out Stack Overflow. Okay, they're trying to do an append mode here. Oh yeah, new file, then true. Okay, so it looks like I have to take advantage of this constructor here called, let me see what he's doing here. True, new file, and true. Without the specified. Let me see. It's something to do with a second argument. File. If the file exists, then it will be truncated to 0 size. I don't want that to happen though. Okay, I'll have to look into this in a bit. Yeah, I can't tell. There's most likely there's like another class that allows you to open it in write mode. Like typically you should be able to say another argument here, like append mode, which is saying construct it but don't delete anything. So I'll have to look into the documentation later. But yeah, for now, be careful if you're opening up a file in write mode. It's gonna clear everything unless you look into appending. All right, so yeah, be careful. Let me see where we're at over here. Okay, let's talk about some applications of writing data. All right, this is useful for really like saving progress. If you're thinking it in the game sense, you're saving your data so you can turn off the computer and boot it back up later again. Right, so you're saving the progress onto your hard drive. This is it'll last longer, and you can load into memory later. Or you can think of this as like logging history. You have to look into append mode for this. Logging history means to kind of keep track of what has happened so far. So sometimes it's necessary to write applications that constantly store the history. This way, like a future programmer or your coworker can study the log and see how your application is performing. Or maybe they wanted to study what has happened so far, so they can debug things easier. If you're into machine learning, you'll end up doing some large experiments. Experiments where you would kind of run a program and then kind of save the results. Like let's say you're running statistics and then you save the results, but maybe you want to tweak the program and run it again. So if you're into machine learning, this is kind of what the pipeline looks like. It kind of looks like a trial and error, where you run the program, you analyze the results. If the results are bad, then tweak the implementation and run it again. All right, so you loop this over and over again until you find a good implementation. But finding that good implementation kind of requires you to store all of the results. Right, so then you can look at all the results and see which implementation performed the best. So this is useful stuff, writing output. All right, hopefully that makes sense so far. So yeah, that's it for today, folks. We're just gonna be, all we did was talk about file streams. In summary, we wrote a program that can either load from a file or save to that file. All right, pretty cool stuff. Okay, that's enough for today, folks. Hope you all have a good day. Bye bye.